Moving on to the next question. This question is very tough. So we have to write an example of an odd polynomial function with 3 zeros in factored form. Now, it sounds easy when you first read it, but it's actually really tough. So don't get confused when they say odd polynomial function. That's not the same as odd degree. If you remember an odd polynomial function, what does that satisfy? So that means that f of negative x has to equal negative f of x. It also means that what? It's rotationally symmetrical about the origin. And another way to look at it, if you just look at the equation, is that the function has all odd exponents and no constants. So we got to make sure that this polynomial function that we provide satisfies all of this, and it has 3 x-intercepts. And it's pretty tough to do, to tell you the truth. It's tough to explain as well. There's no like process, no smooth process to follow to do this. Basically, what you can do is you can use something like x cubed minus x. All right, because this function, notice how it's an odd function because all of the exponents are odd. We have this 3 and we have this 1 here, and there are no constants. So it's going to satisfy this algebraic equation. And if we factor this, what can happen is we could take out an x, we'd be left with x squared minus 1. And then that x squared minus 1 is a difference of squares. And notice how we took this function, we factored it, so it's in factored form, and notice how it has 3 x-intercepts at 0, at 1, and at negative 1. But again, getting to this and just realizing that this is how you do it, it's tough to tell. So graphically, the way this function would look, x-intercept at 0, x-intercept at negative 1, at positive 1, and it would look something like this. And notice how it's rotationally symmetrical about the origin as well. Or another way to look at it is if we reflect this in the y-axis and then in the x-axis, we would get the same function. Now, this doesn't necessarily have to be x by itself. You can also have like 4x. And this would end up being x minus 4, and then notice how that's a difference of squares as well. So x minus 2, x plus 2, and then the x-intercepts would be at 2 and negative 2. Or you can use another number that you can take the square root of nicely, so like 9. Then you'd have x minus 3, x plus 3. Right? So in this case, this would be like negative 2 and positive 2. But it could also be negative 3 and positive 3, negative 4, positive 4. Either way works. But the trick is getting all of these characteristics to match. So all of the exponents have to be odd for the expanded function, which they are. There's no constants. And when we factor it, we end up getting 3 zeros. And sometimes to think of that and to be able to get to that is fairly tough, hence why I thought this was a tough question. But once the explanation is given, it's not too bad.